is going to be hopefully informative. If you have questions, I think we should be able to use Teams to take care of that. I'd like to try and get through the slides first, and then I have a whole bunch of demos. Basically what I've done is taken a lot of the examples that I've used in presentations previously and from the book, Expert T-SQL Window Functions in SQL Server, and have those so I can present them to you. And then we'll finish up with a look at the new window functions in the DAX language. That was released in Power BI 2022, December edition. So if you have any version of Power BI December or beyond, you have the functions in Power BI. I have not checked or verified if they're included in the analysis services engine that's available on Azure, but I would assume they are. But I don't believe they're available in Analysis Services 2022 at this point. They may be added in a service pack or something in the future, but currently I don't believe they're there. So let's go ahead and get started. I believe with the slides, Morali was showing me that you guys can actually move around within the slides. If you want to skip ahead or go back and look at something I've covered too fast, you've got that option. Again, Morali gave you the intro. I've been a consultant for most of my career, and started with SQL Server back on the first release. Ran on OS2 version 4.1.2, I think, 4.21 or 4.1.2, can't remember anymore. But all you had was a little text window you could write queries in. That was about it. And so it was a long time ago. Seems far, far away in a galaxy far, far away. And now we have all this career building opportunities within the SQL product stack, and it just keeps getting better and better. So if you haven't got a copy of this book, I recommend you get it. I have to do the pitch, the sell. I made all of like $300 off this whole thing writing a book. So I don't necessarily recommend it if you want to get rich, unless you're writing spicy novels or something. But technical books, it was fun to get it done and get it out there, but it's certainly not paying the bills. So, but it is a useful book. I refer to it all the time. Especially the chapters that I didn't write. I learned things from them as well. And Kathy Kellenberger's another member of our local community and group here in St. Louis. Okay, agenda. I think I said that already. Basic SQL window functions. What are the basics of window functions, how they operate, and then some examples of what you can do with them. And then we're going to take a look at the only published article I can find on the Power BI window functions and some of the examples they have. And in doing so, hope to show you Tabular Editor 3 and how you can use that to work with models in Power BI. If you haven't heard of it or you don't use it, there's a free version, Tabular Editor 2. Version 3 though is worth, I got the Enterprise Edition, and for me, it's worth the $95 a month. For the amount of time, I mean, I should just charge my clients that through, because I save so much time using that tool. And more of time permits. We have an hour and a half, of which we burned 10 minutes. So we'll just keep going here. So what are Windows functions good for? They're great for doing things like ranking. There's different ranking options. There's moving averages. Statistics, you can do percentiles and other statistical functions, running totals and trends, comparing a row item to the parent or the total of a group. And inventory burn downs is one that I just came across and you came up with this past week. And I don't have that as an example, but I could talk to it if anyone was interested. Islands and gaps. That's not one I'll cover, but it's in the book. One of the other authors in the book covered that very, very well. An example of that would be help desk tickets. You have an incident, an outage, and you need to be able to know when did the outage start, when did it end. We had 500 tickets came in that kind of overlap. Was it all one incident? Was it multiple incidents? And with the islands and gap technique, you can figure that out and figure out where one event started and ended and the next one started and began. Welcome. So the basic structure of a window function is a function name, so like sum or average, over, and then you have either an optional partition clause and an order by clause. So you say over and then some columns, and then order it by order by some columns, and we'll order those columns and basically give each one a unique row ID that you can then do math on to determine values from previous rows or following rows, and also bucket things into groups. So in other words, the partition can be, say, a product category. I want to get a total by the product category, and then maybe the product subcategory. I can have those two totals automatically calculated in one pass. And normally, to write these in the past, you would have had to write a sum, union that together with another sum, or use the CTE and join it and do all kinds of crazy SQL logic and temp tables to make that work. Well, now you can do it all within window functions. Now this behaves different. I can't get it to auto advance here. So here's an example of a Windows function. I'm gonna have to get my glasses out. This is really hard to see on the screen because this is a lot of firsts for me here. I haven't presented using Teams before, so didn't realize I'm not gonna be able to read my own screen. So this is an example of calculating a total and a percent total. So to do that, I have to come up with the sales amount by customer. So first section here is just the regular columns, and then a sum of the sales amount over a partition of the customer key, and I'll call that a customer sale amount. So for every row that has that customer key, it's going to group, calculate the total sales. And then the second one, it's over everything. There's no filters, there's no restrictions. It's going to give me a total of all sales. The next column, I'm taking and calculating the percent of parent, I believe, or percent of customer total. So I take the sale amount, which is the current row, and I divide that by that first calculation we have there where we're actually calculating the sale by the customer. And then I can say also that sale is a percent of total. And then you can order by and do your various things. So let's take a look. What does that look like? So I don't think this is doing my animations, so we're just going to talk to it. What I did here is just highlight kind of the blocks that the window function defines. So the first block we did was we partitioned by the customer key. In this case, we have 3 different customer keys in the results. The first one has 4 orders, 4 different products, sales amounts totaled. We get our total for the customer. You see it repeats because it's for the customer. And then we get the total sales amount. That repeats down all the rows because that's for all the rows that are in this result set. And then we can calculate the percentages based on those other columns. So in effect, we've defined those virtual columns, which we can then use in another virtual column to calculate the percentage. And order within the rows is what defines the rows. So the order by will define the rows within the range. So it's almost like a subsort. So it will sort, in this case, by the product key within that customer. So now if I want to say, if I could sort by the sales amount, the total sales amount for that product, and say what was that customer's biggest sale, or the product they spent the most money on, you could do all that types of things within that. So next section of the window functions are actually the window framing function or parameters, and that allows you to navigate, kind of move around. So if you think of it, the results within the window function is like a sub table, and that's where working with DAX, it all make real good sense because DAX, you're always dealing with the table. But in SQL, we don't usually have a table as a result within a query. It's the result of the query. Well, here we're in effect saying I'm creating a partition, and within that partition, I want to be able to navigate. And by having rows between, and you have rows between, unbounded, preceding, and current. So basically what that's doing is it's saying, give me everything from the beginning of time on this ordering to the current row, and sum that up. So that way I could get a say a year-to-date total by using that. Yeah, and I wish I could switch and go run this, but I have all these examples ready to run too. So we'll do that in a minute. But that's just an example. We'll go through and actually run some actual code. You can get to see these things work. So there's actually a lot to the Windows options and framing options. So you can say rows unbounded preceding. So that's everything before. Rows, X number of rows preceding. So give me the 10 prior rows, the next, the following, unbounded following rows. So there's lots of ways you can play with these parameters to affect a different range of rows falling into your aggregate. Yeah, and the other thing to know is that rows with a tie based on the order by clause will be merged. So that's one of the things you want to double check. And there's some similar behavior from the reading I've done with the DAX functions that you want to be careful of as well. So what are the functions you can actually use with the Windows partition, order by, and all the other bits? You can do average. There's a checksum function, count big, max, min, sub, standard deviation p, var, and var p. There's, I believe, a few more. Rank, dense rank, n-tile, and row number. And SQL 2019, I think, added a couple as well. And then the other Windows functions, more analytic, cumulative distribution, first and last value, which are handy for if you're doing non-additive measures like a beginning balance, ending balance. Lead and lag, that returns a following value based on an offset. And there's an equivalent in the DAX, they actually call it offset. And then a plus or minus value instead of having different terms, lead and lag. Percentile continuous distribution or percentile based on discrete column values, and percent rank. So those are all the things you can do. And then in DAX, it's much simpler. There's a lot fewer things you can do. But again, it's DAX, so you already have a lot of things you can do and mash the data around and change things pretty easily. So there's three main functions: index, which will return the nth row of a table; offset, which returns rows relative to the current row, positive or minus; and then window, which defines a window of rows relative to the current row, and it can use relative or absolute offsets. And common arguments, very much like the over clause in SQL, is order by and partition by. So we're going to do a bunch of demonstrations. I'll just show you reference slide, finish out the slides, and we'll come back to questions later on. So let's go ahead. I'm going to go ahead and stop presenting from the slide deck and switch over to, did it close my? All right, I'm gonna have to open my files back up because it closed my management studio. So it'll just be a second while this fires up, and then I'll share once it's live. Okay, where is my user group presentations? Give me a second. I'm going to open these all up. Hopefully it opens them in a nice order. And of course not, it opened them in reverse order. Okay, let me go ahead and share the screen while those are coming up. All right, so the first example, you may say, well, I can do that in SQL already, right? I can do all these things without using Windows functions. Yes, you can, but Windows functions also give you a lot of performance benefits as well over just doing it the hard way in SQL. So this first example is just going to do some aggregate column totals by doing subselects. So if we run this, we'll set statistics IO on and off and do all that. And we'll get our stats. Turn that on. Oop.
We'll try to shut it off. I'm sure
So we've got our client stats. Looks like total execution time 278. That's not bad. Then again, it's the only thing running on this machine. So let's go look at the common table expression version, which is a little better. And that came back, total execution time is 62 milliseconds. So that was considerably better than, it's like almost 5 times faster. And really there, the difference was we did our aggregation in one pass and then returned it with the join to the CTE. And the third, but using window functions. And here, let me see if I can make this a little bigger. So it's basically the same approaches, but in a much more compact, simpler format. Just saying sum, that's my aggregate function, over partition by the customer key, and then an alias. And taking the sum, average count, min, max, and same things was doing before. And this we're aggregating to the customer level. Let's look at our stats. You guys, I don't know if you can read that or not, but that got us down to 44. And here we do a window function to do a little more work. So we're going to do our total sales, customer sales, and those percent calculations. So this is the one that was in the slide deck. Okay, so we get slightly different results. We get the other columns. It's doing a lot more work. And our total execution time is 52 milliseconds. So we did a lot more complex work to get a result back in a much simpler query than we would have otherwise, and it performs better. So right there, you have to be sold on window functions. Done. I can leave and go home now, right? No? Okay. I think it's that. Any questions at this point? I think that's it for the first one. Yes.
But I think it's more of a generic question.
Sure.
Question is there you're learning DAX? I use SQL already.
If you're going to be building analysis services cubes in tabular analysis services, yes. Or you're going to be working with Power BI, yes. If you're not, if you're solely just working on, presenting and working with SQL and those engines, you don't have to. But DAX within Power BI, it's a must. It's like with the old analysis services, you had to learn MDX. And I used to present on that a lot. And my take on it is, if you know SQL and you're a god at SQL, just start over. Open your head up, take that brain out, put a fresh one in, and start to learn MDX. DAX is kind of the same way because how it works with filter contexts and things, I still don't have it perfectly internalized. And because I don't get to work with it all the time. I get to work with it in fits and starts. So I get to get where I feel like, yeah, I'm really good at this now. And then I'm off on something else for 2 months, come back to it and back to scratching my head and pulling up examples of what I did before. But tools help with that, and we'll cover that a little bit near the end of how you can leverage the tools to be your brain annex and build out templates for your calculations that will work, and you can use them like a library. So yeah, learning DAX, it depends on what you want to do. I love working in the BI space, and so for me to stay there, I think, yeah, I have to. Do I want to learn Azure ADF? Yeah, I don't like working with SSI as much anymore, but I still do. But I really don't want to learn that. I'd rather focus on the DAX and the Power BI. But that's me.
I hope that answered the question. But also, I think to supplement to the question itself, I feel like the bigger question might be why DAX when everything comes out of the Power Query directly. And I know in some case, Microsoft recommends us to write everything as a measure instead of just using the columns directly that come out of Power Query.
Right.
So in that case, DAX is also very important.
Very important.
To know, right? Any other reason other than just a recommendation why we should use DAX measures versus or DAX calculated tables versus just using Power Query?
You can get, if you think about it, what made MDX important? MDX allowed you to traverse pre-aggregated data on disk very fast and get to a result. Whereas if you ran that same query in a database, it might be doing table scans after table scan after table scan. Whereas in the analysis services engine, it says, oh, you want a month-to-date total. Well, I have totals by day, by product. I can give that to you. I've already pre-aggregated. I'll go grab it. Or maybe it's a month level aggregate by customer. It's already done the work. It goes and grabs it. It's already pre-aggregated things based on, you can do it by usage and other ways. Whereas in the tabular model with DAX, it's an in-memory model. So everything's in memory, and the less stuff you have to have in memory, the faster your model is going to be, the more things you can put in it. So if you're putting all your measures pre-calculated into that in-memory model when they could be a DAX measure, you're actually slowing your model down, because now it might have to swap from memory to disk potentially, or you won't fit as much stuff in memory on that big server you're paying for on the cloud. It just makes things so that you can get more done with less. So if you're actually, one of the things that tools is that I've seen is you can look for measures that aren't used. So you can take your Power BI model and run it through this tool, and it'll say, hey, you've got 5 columns that are never used, never referenced, they're hidden, they're never used, get rid of them. Or they're not used, the calculations are never used. So there's some things that can be done to speed it up. And again, anything you can do to shrink of what's in memory, it's going to make it faster. It's less to traverse, less to aggregate, and you can put more things in, more details that are important for slicing and dicing. So I hope that answers the question.
Yeah, thank you. Thank you.
All right, so next, ranking functions. So ranking functions are, I want to know who came in first, who's on first, what's on second. I don't know who's on third, that sort of thing. This will tell you. And again, it still works using the over function. You could use a row number, apply a row number and order it, that'll tell you. But that doesn't handle ties. Ranking functions will handle ties. So let me make sure I turn off the stats. And we're already in the right database. So again, we're joining salesperson in, and we're going to run that and see what we get. Oh, I grabbed part of the comment. Need to switch those to proper comments. Oh, you know what? This is using the wrong other database, not the DW database. There we go. So does anyone know if Windows 10 has a zoom it key?
Control-1 for.
Well, that didn't do it. Oh, that switched the. That was interesting. I don't know what that did. Yeah, that's the other first. This computer got updated to Windows 10 while I wasn't using it, so I'm not. I'm kind of lost in Windows 10 just a little bit. All right, so again, this gave me a row number, ranked them, but it's quite likely, quite possible we could have ties depending on the data set. So that's where the ranking functions come in, and they are dense rank, percentile, and in this case, we're going to give you an example. We're going to grab the, first of all, run this. We're going to get the row number, and we're going to, why am I, okay, that's postal code, so we got it. My result window does not look like my query. So I can see the whole thing. Something weird happened there. Okay, so I should see, did I run the, okay, I ran, no? Okay, that's why I ran the first one only. Okay. But I still expected to see two row numbers, and I didn't, did I? There we go. That was weird. Okay, because I know what I did. I ran the first one, then looked at the second one. So again, we can have row numbers based on different sets within that, so different order over and order bys, which can be very handy. So we can find our top, in one query, we can find out what our top zip code is, what our top product is, do a lot of different things. So let's go a little further. This time we're going to use the AdventureWorks DW. And we're going to do a rank and call that sales rank. And we're going to take that, ordering it by year, month, and sales amount. So we can figure out what month we sold the most data or sold the most products. So our sales rank, our top sales period was 2010-12. And the product, whatever product key that is, whatever product that is. Then we can do the same for the months and years and so on. So we can come up with those numbers and then we can order it based on them. The dense rank allows you to determine, break ties basically. So if you have a tie, it'll break the tie for you. So if you see, that's what I'm trying to remember. It's how it numbers it. So in other words, you can't have two silver medals at the Olympics. Right. So in this case, the dense rank gives you the 1, 2, 2, 3, 3, 3, so on, whereas the normal rank gives you 1, 2, 2, 4. So it skips the 3.
Oh, it keeps the tie, it skips the one
yeah.
behind it. That's right. Thank you.
Yeah, so that's something to know because you'll run into that.
Oh, yeah.
You absolutely will run into that. All right, so let's finish up on this one. And this is basically just more examples. And I will make all these available. I did have them on it was SkyDrive a long time ago, but when I checked the link, it's busted. So I took that out, the slide, and I'll make sure that gets sent out. And then it's a sales rank. So we did a different rank, but we're ranking in this case by the year of the order date, the month of the order date, and the sales amount descending. So we can get top and bottom sales ranks, or in effect. All right. So that's ranking. And so how many of you know what standard deviation is? Have you done? Everyone's probably done a statistics class whether you wanted to or not. So standard deviation and variance for population. Those are statistical functions that if you're into that, you know how to use them. I don't. I've had to use percentile on a few reports or come up with a way to do percentile before there were window functions. And some of the analytic functions. Here's your cumulative distribution, percent rank, percentile rank. Yeah. Yeah. So to do that is, to have to do that in a report in SQL, that's not fun. I use OneNote as a brain annex, and I have examples of all kinds of these things in my OneNote brain annex that I'm hoping I never ever have to go back to, because these things just work. So what's here's an example. Find the median employee salary in each department. Find the median employee salary in each department exact value. So one is kind of interpolated the average, and the other is what's the exact mean or median. Continuous or discrete. So again, there's some cumulative percent rank. I think this is similar to one we did already. Okay, so finally we're going to take a look at something other than the functions, that operate over those sets, and we're going to look at. We're going to say we're going to improve this to get a previous salary. So we can. I'm looking for it in here. So here I'm doing this with a CTE, and I think we could do this with a lag function as well. Is you could find out someone's previous salary by doing that, and in effect you're saying apply a row number, but then when you're looking at it, select that employee, and then find the row number that's previous date for that employee. But those are things you can do with a lag function as well. Okay, we're going to skip that one. That's a weird function that nobody uses. And this is our cumulative example. Let's go ahead and turn on stats and again show you the difference in the performance. So old school, we're just taking the sum, and in this case we're cross-joining, taking this from sales, cross-join where the sales amount is less than the sales amount. We're cross-joining to itself, which is a very old and nasty way to do this range type query. And hopefully this poor little laptop comes back. We just might want to not do this one. Yeah, we're going to skip this one. This one I've got a better example in the book examples. So. And we're going to skip those. One of the things that's often handy that not a lot of people have is a way to generate a calendar table. And that becomes important in one of the examples we're going to do later. And this is also something that's important in DAX, is being able to calculate a calendar table. They built some capabilities in to kind of do that automatically, but most organizations will have their own calendar with their own fiscal dates and things like that. But if you don't have that, it's really handy to have a way to generate one. This script will do that for you with a lot of date math capability built into it for like previous period, period names, abbreviations, days, and things you can use for in your queries for figuring things out. Big reason to have it with window functions is dealing with gaps in dates. Because if I have a set of data and I want to compare period over period, but I didn't have any sales last period, I don't get a row. There's just nothing there. So it'll compare April to February because there's no row for March. So by using a date table kind of as your framework, you're going to hang things on your date, your math, your summarized columns to the date table, then you can get those gaps filled. You'll get a 0 for March instead. So this is an example, something that I put out here before, and I'll share that with you guys. It's really handy to have that. We're going to move next to examples from the book. And these are all build upon each other. And a lot of what I've worked on over the years is financial reporting or other business reporting, where you're always comparing period over period or one group to another, and being able to add things up and do that and be able to create time calculation measures for reporting is very important. A lot of times it gets done within a report or within Excel, and it can get very obtuse and very complicated and hard to figure out for end users. If you can build it into your query and just present it as data, way better. Another example why you do that in DAX is you can create those time calculations in DAX and make them available to an end user. If they want to have prior year, oh look, folder that has previous period function or calculations. I open it up, prior year sales, drag drop. I now have a column for prior year sales. So a lot you can do with that. This is like a base example we're going to use again and again. I'm going to make sure this is AdventureWorks. Yes. So this is just your basic group by query. It's just pulling your product key, order date, order year, and order month, and the sales amount, summing that up, for a date range. So we're going to use that and build off of it. So the first thing we do after that is we're going to add those aggregation columns. The other example we looked at had an all sales, like what are the total of all sales across the selection range? And then what are the sales for the product? What are the ratio of those sales? And so it's really easy to arrive at that using the partition query, the partition functions. So what does it look like? The all sales, again, we do our sum, and it's going to be over the sales period over an empty value. So no order by no partition clause. That'll return all sales for all the data within the selected range of the where clause. The first one is just the sum of sales is going to be for the year and a month. So it'll be for that one period. The next one is partitioning by product key. So within that selection, year, month, product key is going to get the total for the product key. And the next one is the ratio for that product to the ratio of all sales. And so what we do here is we can actually combine multiple functions within one. So here I have the query that's returning all sales. And I have oh, actually I got that wrong. So that's the sum of all sales and then the sum for product sales. So those two calculations, this should not be indented. That's what's throwing me off. These two calculated columns are then combined into this one. And you can do that. There's a few rules to it, but it doesn't care. I'm taking and running the sum of a sum. So my window function is the sum of the sum. And it works. It does the job. And so now I can combine those together, just like any other calculated column, and do the division. You may have to check for divide by 0 if you really want to be thorough. And then you get the ratio. So the next one, we're going to do a little more. So let me get this a little bigger so you guys can see it. So we're going to define a number of other measures. So we already had sales amount, all sales, annual sales. So we're going to build a window that goes from defines sales for the year based on the current row, for the month based on the current row, all product sales, and then all the various ratios. So it starts to get, you'll notice it starts to get very complex looking. There's a lot of bits and pieces to putting it together, but it's all just building piece on piece. So once you start working with them and get that basic handling of a measure down, now you can combine them. And when it gets really complicated and you're having a hard time keeping all the math straight, you turn this into a common table expression, name the columns, and now you can do the math of dividing A by B using nice pretty column names like all sales, dividing product sales into all sales, or whatever the calculation is. So what I've done here is just highlight what the different sections are, what the kind of pseudocode of what's going on, so it's a little easier to keep track of. So we have all our base measures, and then we combine them to come up with a ratio. So we're basically saying, give me the sum of sales amount for the product divided by all sales. Sum of sales amount for the year, product key in the year, divide that by all sales, and so on. We'll go ahead and run that. You know what? Output. Try and get the query results so you guys can actually see them. Oh man, I bet you have to restart it.
SSM is terrible. We will not take some of the options right away. Right?
Well, I've taken enough time on that. So can you guys see it at all? I mean, is it just someone want to give me feedback? I can't see what you see, but is it like so tiny you can't see the results?
Yeah. If you don't mind downloading.
I could just as easily close and reopen this and start over too. That'll just take a moment. or not. Did it just lock up? I think that's where we were at. And I'm hoping by opening them in descending order that it'll put the first one I want as the first tab. It looks like it's doing that, so that'll save some hassle. Yep, so let's run that and see what we get. And it didn't change, great. Okay, I'm not gonna mess with that again. Unless somebody wants to tell me what I did wrong, that would be helpful, because that's just really tiny. So, but again, bottom line, we're building on step by step each thing to come up with new calculations. The next, we have percent of parent and annual monthly sales. So we're just adding in another calculation into that mix. And again, we're just going to, in this case, we're using a CTE as the base. I mentioned that before. So the common table expression that'll do the work. So it's all the same calculations, all the same logic, but instead of doing all the math up here and ending up with, partition query functions nested within each other, which gets really ugly and hard for your brain to figure out, name them, annual sales, month, all sales, and now creating those calculations with a select over the CTE result makes it a lot easier to understand. So again, this is basically the same results, but instead of having all the pieces in the result, we get the end result we want. We get rid of those kind of intermediary columns that we needed to get the result we want. So we can narrow it down. So, and the common table expression also comes in handy because we have to deal with that date gap issue. And so if we use the CTE, we can plug that date table in there and take care of that. All right. So day level aggregates with rolling totals for month to date, quarter to date, year to date. So rolling totals are different. This is where I'm going to take a little look here. I'm going to zoom in. And we're going to look at what's different about this calculation. So again, we're still doing sum over sales amount. We're still partitioning by product, key, year, and this time we're adding in month. We're ordering by product, key, and the order date, but we're picking rows between unbounded preceding and the current row. And what that does is that gives us a month to date total. So we'll roll it up as that window, the rows in that window are moved through, the days going up, and it's going to go from that first row, the unbounded preceding row, which should be the first day of the month, through to the current row and sum them all up. But that happens row by row, so you'll get a running, growing total month to date.
Is that unbound proceeding based upon the month in or is that, how are we defining that should aggregate at the month level? I guess is my...
That it's defined by the partition.
Okay. So because, all right, so that is,
yeah.
Because we added months to the partition, that's how.
Because the other way you can do it is you can use you can say the previous 10 or 10 rows. Well, there may be 5 rows or maybe 100 rows. You don't know how many rows are in that window. This allows it to say, hey, I'll start at the beginning of that window and carry it forward. So like the example slide I had up that had like 5 products, 1 product, and 4 products, in the number of rows, it's going to go all the way to the beginning and then do the aggregate down all those rows. Whereas if there's only 1 row, it's done. And
I'm a little bit of a lazy developer. So instead of doing the sum with the group by, sometimes I use the sum over so that I could do the same thing with unbounded preceding and unbounded following. Especially when I have like 20 columns to do a group by on, and there are some other calculations going on in those columns, then it makes it a lot more complicated for us to write the group by clause. I just do the over, and then I use the unbounded preceding and unbounded following, so it does it for the entire partition, for each of the partitions. Total sum that way.
And then do you filter within there somehow?
I mean, depending on what I want to do, yes. So I
That's
usually don't do a sum of sum in that case.
I'm gonna talk to you after and add that to my list of tricks. I like that.
Sure. Thanks.
We'll run that. And
when did you hit Windows and plus? Windows key and plus?
okay. If I can find plus on this keyboard. Over there, Shift plus.
Or Windows, if you got a Win, oh, I'm sorry, you on a Mac.
There we go. Haha.
Now you can hit Control. Got movable window.
Nice. I knew it was in there somewhere.
Zooming percent is set up by that magnifier. I have to hit the X to close magnifier.
Okay. Well, I might just slide it out of the way until we need it again. All right. So yeah, there we go. Now you guys can see you got the sales for the period. Month to date's the same. And then as you look down, we'll scroll down, the month to date keeps going up, and then it will reset when you get down to the next month. So we get down to January, it resets and resets for all of them because it's a new year. Then you go down, keep going down. So it'll reset on the month and keeps quarter keeps aggregating, year keeps aggregating, and so on. And then a running total. All right, so I might have to.
No, you think you could just hit X? Get out of that little.
Escape didn't work.
Yeah, I know. You have to go up and X out of it.
All right.
That might be another setting somewhere.
Yeah, there's probably another hotkey for it.
Right.
Yeah, so that's the magic of using the rows between, is you can create those rolling measures very, very easily. So let's go to 10.6, handling gaps. This is what I talked about earlier, where if you're wanting to do something at a day level or a month level and there's gaps, you need to then link to another table. So how you can do that is, we're going to run this and we'll see that there's some gaps. So we got order month 1, 4, 5, 6, 7, 8, 9, 10, 12. So we're missing months 2 and 3 and month 11. Go ahead and close a couple of these. So how do we solve that? Easiest way is to bring in that calendar. And what I did is I did a cross join to the product table. So I get a day, because the product's the granularity that I have my data at that I'm reporting at. So I get a row per day per product, which I then join to the fact table to get the actual totals, the sums that I'm looking for. So I got my CTE of product period, and that's really all it's doing. Could run just that part. Oops, I need that. So that's basically what's coming back. Product key, product ID, date key. So I got a little more info into that one. And then the rest of the query is basically what we had before. But this time we can include our product ID, so we've got a little more information to look at. And now, what was that again?
Windows plus.
Plus, Shift plus.
Just Windows. There you
Okay.
go. And Windows escape will close it.
Ah. So there we see our order month, 2 and 3 are there, sales are 0. Didn't affect our aggregates. And same down for month 11. Okay, thank you. So there's really nothing magical about it. It's the tricks that I learned to figure out how to do all this stuff. So now we get into more of the tricky stuff, like what are some of the time calculations, things that you know, if you do DAX every day, you have all these things figured out. But in SQL, it's not so easy. Well, the window functions allow you to do this. So you can say, I want to be able to calculate same period prior year variance. I want to know, are sales up or down based on the same period the prior year? Well, this will allow us to do that. So again, I'm doing that product period to make sure I don't have any gaps. And then we're limiting it to the products that are actually in the fact sales table, and then pulling that together. I don't remember if there's anything else in this one. So here, the trick is we're using the lag function instead of the unbounded. So we've got our sales year to date calculations using the rows between operator, but for the previous period, same sales period, same month prior year, we're using lag of our sum, but then we're giving it the offset. We're going to lag 12 periods. So we're aggregating by 12, right, by year and month. So we're going to get a bucket per period for that product. And then we just order that by calendar year and calendar month. So it knows, go back on that list, 12 months, grab that. If you wanted 6 months, 3 months, you change that lag value and you'll get it. You'll get the offset. So we'll go ahead and run that. So we get down to, we had no previous sales to 2011 because we've limited our query. So we get to 2012 and then we get that value. So our number is different. And if we go back and look at the first, so what do you get? 469,823, 469,823. So it worked perfectly. Okay. All right, so this one we're going to look at calculating for the same month prior year, the difference and percent difference. So again, we're just building on top of that. So we can go ahead and just run this because you know where this is going. But you see how ugly this is getting? You know, to make that all work for these calculations, here's like the pseudocode. Percent growth is a current year minus the prior year divided by the prior year. Okay, that's what this is doing. You look at that and you tell me that's what that's doing, right? Without the pseudocode. without being that familiar with Windows functions. Whereas if we break it down, I think the next example does it, where you actually name them in the CTE, it makes it a whole lot simpler because you just work off the component pieces. Here we are. And let's go down to the next year. And we can see our growth percentages were negative on some of those products, and then they go up. And again, same basic steps to get there. You're just adding in the lag function in this case to be able to look back, and then how you combine the results of each individual columns is up to you in coming up with those calculations. And this example is comparing the current month to the prior month. So this is like a running. So instead of prior year change, you're looking at the previous month. And so again, we're going to do that product period. But we're going to do it just a little. This is our year to date. And the difference here is we're lagging by 1 instead of 12. So we're only going back 1 month, getting the balance from the prior period. So then we can do the calculation here. The current month less prior month divided by prior month. Get your growth percent. So there we are. Is there any way to make that little window bigger? It's not.
You can, yeah. You have to go to settings though.
There's a plus sign of that.
That will zoom in the zoom amount of the window at standard size.
It won't change the window size.
Change the size of
Yep.
the window, you have to go into magnifier settings.
Yeah, so we calculate the growth as a dollar number and it's a percent. And then with these results, if you dump them into a table or a CTE, then you can do other calculations on top of that. You can rank them. Say, give me the top growth ones by percent. So again, we're just scratching the surface of what we can do. Another fun one, this is one of my favorites, moving averages. And they're basically where you're saying, I want to calculate the average over a moving window because prices fluctuate, right? It may be, if you're looking at the example I built a report around was CPI data. So consumer price index, except it's PPI, producer price index. So those prices change. So what's the trend? Where's it going? Because that data can be really jagged and you can't see a trend. But if you create a moving average, say a 12-month moving average or a 6-month moving average, it flattens that trend out. You can see it a lot better what's going on. And so again, we're going to be using that lag function to figure that out. So in this case, I've got a 3-month moving average. And for that, I'm saying using rows between 2 rows preceding and the current row. So that's a total of 3 rows. So that's when you got to be careful of. It's kind of like a zero indexed array. Your current row counts. So if you want 3 rows, you go back 2. That's an easy one. If you aren't aware of it, you can end up thinking you need 3 rows and you can get 4 months of data instead of 3. So again, we're doing a sales 3-month moving average, a moving total, a 12-month moving average, and I've got a chart that'll show you that puts this all up. Again, it's just using the basic functions of defining the windows and doing the calculations over them. And this one was a little trickier because I had to check. So you see case when the count over this is pitched. So, and why I did this is a test, right? If I want a 12-month moving average, what happens at the beginning of the time frame when I don't have 12 months? So if I have 5 years of data for that first year, I don't have 12 months of data previous to it. So what I did here is use a case statement to check the count of how many buckets or how many rows are in that preceding window. And if it's not 12, I don't do the calculation. But if it is 12, if I have 12 buckets that I can do an average on, then I do it. Otherwise, there's your average is just the average for the first month, and average 2, and then 3 and 4 and so on. It's not a 12-month moving average. So basically, if it's not 12 months, it returns null. Otherwise, it'll do the calculation. And again, all this nastiness is done in a CTE. So this is like a 3-level operation. The product period, the monthly summary, all the bits and pieces, and then the results that then, excuse me, that then take and do the math at the column levels. I'm not going to be able to get through this. All right. So let's go ahead and run this one. Oops, I have something to highlight, don't I? And let's hit the zoom. And you'll see right away what I was talking about. This is a 3-month moving average. You don't have 3 months of data until the 3rd month. Same goes for the 12-month. And then you can do your growth percentages and that based off that. So again, really useful. And with that, I think we're almost done with the examples. One more where we're adding prior year-to-date calculations. I'm just going to run this one because it just running out of time. So then I could do the percents of the growth amount, and the growth percents. So again, this is a very robust set of calculations over a base set of data. So doing all these time calculations and different ways of looking at it, presenting statistics that financial types absolutely love. And it's not hard to do. It just takes learning these, basic things. Yes, Marley?
There are a couple of questions on the thing. I can read it out.
Okay. Or if we could wait, I've got like two more examples and an Excel sheet to throw up, and then we can open it to questions. And the next one is handling the gaps and adding a rate of change calculation. Rate of change is just another way of looking for trend, presenting trend data. And it's going to be kind of hard to understand it without seeing the chart. So we'll run it, and then we'll go look at the data in an Excel chart. So we calculate the 3/12 and a 12/12 rate of change. And the math is will be in the examples. But it's if you look up rate of change calculations, it's not super advanced, but it's really useful because it shows how things are changing. Is it trending up or trending down? And it smooths that curve out and makes it a lot more understandable from the data perspective. But again, it relies on those moving averages. So you have to have all the bits and pieces in place to have complete 12-month moving averages and such. And who here knows what a Pareto is, or the Pareto rule? Ever heard of 80-20 rule? It's basically, came up by some Italian guy named, with the last name of Pareto, and he was a bright guy. And problem solving, we use it all the time. We're at 20% of the problems are not the ones. 80% of the volume of problems is caused by 20% of the users. Oops, did I say that? I mean, systems. But you know what I mean. And so the Pareto is basically calculated by dividing your cumulative number by the total number, and that'll throw out basically a not a percentage, but a number you can then use to draw a Pareto chart with. And we just go ahead and run this. See the data real quick, and we'll show it in Excel. So in this case, cumulative sales comes from one category. Road bikes is almost 80% of the sales. So let's take a look at that, what that looks like in Excel. I got the right one here. There we go. So that's the data from that query put on a chart. So you can see that the majority of the sales are of a small number of products. So you can very quickly determine, hey, are we spending enough on marketing, things we could do to sell more, or maybe we got to bump up sales on these other guys that are the laggards, or maybe we just get rid of some things that are, look at your costs as well and say, we're spending more marketing all these guys that aren't selling. Is our marketing no good, or nobody's interested? What's the deal? Then it gives you actionable information, things you can work on. And the rate of change data. So the raw data is the charts. So you see the lines, that's each period's data. And then the orange is your 3/12 rate of change. So basically taking the 3-month moving at, basically the rate of change for the 3-month periods versus the 12-month periods. So again, it smooths that out, and it makes it a lot easier to see. There's a definite positive trend. There's a lot of other statistical techniques you can do to look for outliers and things, but this smooths out the data and gives you a good idea what's going on with the trend. And again, it can all be done in SQL, and with the tools you have, you don't have to learn anything new other than how to use the not the Power BI, the window functions. I'm thinking ahead that we haven't talked about the Power BI yet, so let's take a couple questions and then we'll jump back on the Power BI, cover that real quick. And I think that's going to have to be like a follow-up session once they put more information out about it. At this point, it's still kind of pre-release. There's not a lot of people know how to use it yet, and from what I can see, it's going to be very powerful, just like the Windows functions in SQL. So, Morali, what questions do they have?
Now that does it use the window book, window function book, or how to use the window functions?
How to use which?
The window function book that you showed the cover to use the table window functions.
Yes. Yeah, and in the errata for the book, I have that date table script.
Oh,
yeah. And I think you can actually, I did a search to grab the latest URL for the book, and I found it on GitHub. And now I know I have access to it on GitHub, but it looks like the errata for the book is available on GitHub.
Nice.
So.
Yeah, if the GitHub
pulling out posts.
That may be why we're not selling so many copies of the book. You can go get the examples for free. You don't need the book.
Well, that's Pareto, I guess. Like, have you used Tableau? Is there a SQL for Tableau?
Tableau has its own. I've used Tableau, but it's been years, and Tableau is different. It doesn't have the same concept of a calculation engine, or a model. You still build relationships from different sources, but it's still, I worked with it against a cube, and it was horrible. It was an awful experience. Against SQL sources where it knows how to deal with it, it worked great. MicroStrategy was another one that worked great against SQL sources, not so much against multidimensional. But I don't know if if they'll support the SQL, but DAX is an entirely tabular model thing. So it's in analysis services and it's in Power BI, and that's the only places I'm aware that it exists. Other products, other things on the market in the early 2000s used MDX, Hyperion being one, but I'm not aware of any products outside of Microsoft that use DAX as a language.
Thank you. I mentioned that their company was Tableau. Sorry about that. Also a question about, do you have any book recommendations for the analytics to make business decisions?
I do on my shelf at home. I can't recall any of them off the top of my head. I've got an MBA in a box book that's got a lot of good stuff, because a lot of it has to do with the business, right? And how they run the business and what they're looking at to measure the business. And it's different. Financials are pretty consistent, but a lot of other things, it's very different. A client I'm at, they look at their backlog a tremendous amount, and a lot of statistics off the backlog. And for example, they want to, they have various dates tied to a sales order, and like a promise date. We promise we'll ship it by this date. Well, when did we actually ship it? What's the gap between that? And there's a stat based off that gap in days that throws it into an error bin, basically. Hey, we didn't meet the mark. So there's a stat that's generated off that. So there's a lot of different things that you can do, and a lot of times it's really up to who the audience is at that client. But a good book on MBA and analysis. There's some good analysis with Excel books that actually, come more from a business side, but give you the types of analysis that people want to see, which then you create the tables, the views, queries that produce that result and do it quickly. What our job as IT people, I think, is to save business people from themselves. Like I had planned on having all afternoon, like, to practice this and go through. I got on a call because a Power BI report had failed because someone had not changed the column name for a value. So they had basically, I don't know what the numbers are, it was a part number and a few other things, and the column had a YYYMM value as the column name. And in Power Query, they're taking all these Excel files out of SharePoint, mashing them together, doing a pivot on that column to turn it into a field which they could then use as a period code to join to the date table. And what happened is there was a file for February and a file for March, and the file for March had February's period code in the column. And when Power BI processed it, it blew up. Well, I got the call because most of the data comes out of the data warehouse. And the guy who built this just built it for the business. Somebody asked for it and he made it. And it is a crazy mess. I mean, I pulled the Power BI down. I started peeling through it, trying to figure it out. And finally, I was ready to quit at about noon but I stuck with it until like 3 o'clock, and I got it figured out. But I had to parse through, get access to the SharePoint files, figure out which one it was, and then fix it. And then I couldn't run it because I had to take over the report on the Power BI portal. And so all the connections to the SharePoint site were broken. And thankfully I could use my account and get it set back up and get it to run. So yeah, it was not a good day today. So if I'm a little off, I apologize. But yeah.
If you do at some point find those, please do.
Sure.
We have something this be on YouTube, we'll put on the description.
Yeah, there's some good suggestions, or any book by Stephen Few, at least in terms of presenting information and the way to present it for understanding. So visually, what makes sense for different types of data. Those books are really good. Yeah, and just anything that's about financial reporting, a lot of times if you look at financial reports and the different ratios and things they're looking at, you need to find out what's behind that. But once you do and you know how they're arriving at it, you can build that into your queries and into your reports. We got a few minutes left. I know I brought a book to give away, so someone's going to get a copy of DAX Patterns 2nd edition by my two favorite Italians, Alberto Ferrari and Marco Russo. And if you ever get a chance to see them in person, they are phenomenal. And this is my copy of my book. I can't give that one away. That was one of the freebies I got. I got a copy of the book for getting published. So another bonus. Okay. I'm going to direct everybody to this article on SQL BI. I've played with these and it's phenomenal what you can do. And it's all this, it has the base capabilities of the Windows functions we looked at. It doesn't have all the statistical things, but it has the window. It has the index, so you can say what you want to index and order it by, and how you want to frame that window. So all those things are possible. One of the other things I wanted to show you today is my new favorite tool. So I have their example file loaded up, and I wanted to look at how they built these, what's going on, right? So they've got example of how to use offset, example of the window, doing that rolling average basically. So 6-month moving average. And window apply, and this one I didn't understand yet, so I won't even try. But if you want to look at the code, you can always go and say, okay, what are my calculations, right? And look at it this way. Or you can use a tool like, what's it, DAX Studio or Tabular Editor. Both of them have the similar capabilities in this regard, but Tabular Editor is the absolute bomb if you're trying to clean up a cube or do a lot of bulk work on a project. Like you've got it done and you review with the customer and they're like, yeah, these calculations should be in a folder called X. Okay, highlight them, right click, move them to a folder, done. So in this case, I'm going to connect to that Power BI model that's running in the background. So there it is, it's running on localhost, and I'll say, okay, it'll load it up. I can now explore it. So I can look through it and see all the tables. You can actually add translation. So if I wanted to add Spanish or French, I could add a translation and have someone create the JSON file. It'll export the JSON files with the translations. But the really cool thing I like about this is I can just say script DAX. Boom. All the calculated columns, all the calculated measures in a single script. Now, this is handy because I don't know about you, but every now and then I'll be working on something and I'll have it like so close, it's really close, and then I do something to it and I mess it up and I don't remember what I had before. It's just part of being a developer. You shoot your foot off every now and then. But by using this, I'll open a window, script it, and save it off, date, time, and if I have to, I can go back to it. The cool thing is you can highlight a section of this and apply it. And it'll apply it back to the model, even though it's live in Power BI. It's just treats it like a server, and you've committed a change to the server. And this thing saved my behind on a project. Client out of Chicago bought a company in Mexico. They had built all these Power BI reports over a tabular analysis 2012 cube, but built all the measures, most of the measures, in Power BI, and then aliased them on the reports. So if you're looking at the report, you see the column header, but you don't know what the measure is without like going and digging around to find it. And it was just awful. So what I ended up doing was I tried to connect to the tabular instance. You can't connect to it with the new tools to a 2012 version. It's not supported. I did not know that. So I thought, there's got to be another way to do this. So what I did is I copied the project, upgraded it 2016, published it, pulled the measures out. Oh, there's hardly any in here. There's like 20 measures. Ran a profiler trace, went to Power BI, hit every page, every report file, every page within a report file, captured all the DAX queries, manually pulled it up in this guy against the cube, and it would highlight and tell me any syntax errors, and it would tell me if I had a duplicate measure. And I did, because the same measure was used all over the place in that report. So then I was able to pare it down and go from, I think it was 50K file of code down to about 16K of measures, and get that cleaned up and into the actual cube model instead of in all those Power BI reports. And now they have a copy of their cube running on 2016 with all the measures they use in it, but all their reports still point at the 2012, and they have to rebuild them. I was like 10 hours a month support, right? That was all I was doing. And they got their money's worth. But that was fun. This tool is the bomb. It's absolutely the bomb. It also has a
Sorry, I've got a hard stop. I've got to
okay.
wrap up here. I got to get home and got to do the last one in the building.
Okay. Well, we'll wrap up. One thing with this tool as well, you have a query window, so you can write an evaluate expression here. And one of the examples that is really cool with window functions is you can evaluate, define a variable, and then select the variable back and get the results as a table. So you can kind of see what the window function's doing before you wrap it in the other aggregate function that returns a single measure. So you can do a lot of that right within this tool, a lot easier than you can in Power BI itself. So anyway, I'm done with my sales pitch on that. If there's any questions, I'm sorry we didn't really dive into the Power BI as much, but it's still pretty early in what its capabilities are. And I watched the video, went through their examples, and I couldn't really come up with anything to add to what they've already done. So I highly recommend the links in the slide deck. You should be able to pull that down from the presentation, and you can get there from there. It's SQLBI.com. If you've never heard of them, they're the go-to place. They also have DAX patterns as a website, and again, excellent resource. So with that, we'll wrap up. I want to thank everybody who was on the call, and we're going to do a little drawing here for the book, and I think Julie's got some t-shirts or something else we'll get rid of. And thank you very much. You're a great audience. And
I look forward to the follow-on Power BI sessions.
yeah, well, yeah, because I have need of using these, so I really want to figure them out.
Yep.
And you know, the ability to do those things without, because I built cumulative measures before, and the cube just goes from, the Power BI report goes from running great to just dog slow, because it was doing cumulative differences, like for that inventory burn down. So every row it's looking back. It's just awful. And I looked at the profiler trace on it, was just horrendous.
And you could explain things that you did.
Yeah, it's like, don't touch it. That's not right. All right, enough being silly.